Hello beautiful people, welcome to this YouTube tutorial. In this section we are looking at biology 1, and we are going to look at the properties of water, or the chemistry of water. So this chapter begins with a basic chemistry. If you haven't checked out my YouTube videos about the atom and chemical bonding, please do, because it's the first chapter. Then the properties of water. So let us go jump into the topic and see what we have for today. So our objectives today, we shall look at hydrogen bonding, the properties of water, cohesion and adhesion, then lastly surface tension. I know we are all familiar about water because it's one of the most abundant solvent we have here on the planet, and it's what makes our planet even look unique, because it's water is life. So to begin with the hydrogen bonding, the reason why water is so unique is because of this hydrogen bonding. But have you ever asked yourself what hydrogen bonding is? Or if it's your first time, then today, rest assured, you will understand it more better. So to begin with the model, I have here chemistry models to explain the hydrogen bonding theory. So what we mean by hydrogen bonding is that we have an atom of oxygen in water, and this oxygen is bonded to two hydrogens. So just take this as one molecule of water. So what if you have a cup of water? So how are these atoms bonded in water? So what will happen that oxygen is a more electronegative element. It's a group 6 member. So therefore, in the periodic table, when you go towards the right, elements increase in electronegativity. So electronegativity means that the element draws the electrons towards itself than the neighboring elements. So we have two electrons here, one for oxygen, one for hydrogen. The same case here. But since oxygen is more electronegative, it pulls electrons towards itself. So these electrons are near oxygen than they are to hydrogen. So this produces what we call a partial charge. So it gives oxygen a partial negative and hydrogen a partial positive. So this means that this molecule is polar. So that's why we say water is polar. It's because of the electronegativity in oxygen. So this electronegative oxygen is going to pull electronegative positive hydrogens from the nearby molecule of water. So this is what will happen. So if this is another molecule of water, still electronegative, so this oxygen will pull this hydrogen, and also the nearby oxygen of another water molecule will still do the same. So these bonds that keep on forming between the oxygen and hydrogens are what we call the hydrogen bonds. So these hydrogen bonds are very strong bonds, and that's the reason why it takes you a lot of energy to boil water up to 100 degrees. It's because you're breaking down these bonds, since there are so many of them. And also the reason why hydrogen bonding is so important, because we see it in DNA. It holds the DNA molecule in its 3D form. So they are very important for life. And using this model, so this is how the molecule will look like. So this is my oxygen. This other oxygen will attach to this hydrogen, and this other oxygen will attach to another, and so on. So the molecule will keep on joining to each other, and it will take you time to break down these bonds. Imagine if there are trillion bonds. So that's why it takes longer for water to boil. So now that we've understood the hydrogen bonding, so let us go straight to the properties of water. So there are quite a number of properties of water that makes it a bit a unique solvent. And the first one is that water has what we call a high heat capacity. So what is heat capacity? So just in a lay terms, heat capacity is like, imagine when you heat up a bowl of a kettle of water. Let me say you've put like 1 liter in a kettle, and it takes you like 2 hours to boil that water at a temperature of maybe 300 degrees. So that amount of heat you're putting in and the time it takes for this water to boil is what makes this water have a high heat capacity. So a high heat capacity is the heat required to change to heat 1 gram of water to a temperature of 1 degree Celsius. It means that in every 1 gram of water, for you to change the temperature to 1 degree, that amount of heat you need is what we call the heat capacity. So water has a high heat capacity, meaning that it takes water a long time to change its temperature. So that makes it a very good solvent for living organisms, because we have a lot of changing environments in our bodies. We have temperatures. That's why we have to keep our temperatures constant. Is because if we didn't have water in our body, we would dry up and die, because water plays a very important role in regulating our body temperatures and our internal body systems. So a high heat capacity enables us, like for example, not our body to react so much when we are under a sunny day or in a cold day, because the temperature increases very slow with the large volume of water. So that's why that's one of the properties of water. And the second one is that water has a high heat of evaporation. So still the same thing, it takes a lot of energy for water to evaporate. So that still helps us, we human beings. If water could evaporate very fast, then we could eventually die very fast, because when you imagine exposing yourself to the sunlight and you dry up very quick. But since this molecule, water we have in our bodies as a solvent, it has a very heat of evaporation. That's why it takes us a long time, not even a long time. Never will you ever dry up when you're in the sunshine. Maybe if you take days and days, but the reason why we do not, that doesn't happen, is because of this property of water, of its high heat of evaporation. And also water exists as a solvent. It's a universal solvent. So they say about 60% of our body is made up of water. Our cells, internal cells, our cells, when we shall look at the chapters in the cell, we shall see that most of the cell, the cytoplasm, the cytosol, most of the nucleus, most of all those structures consist of water. They have water in them. So it's a universal solvent. So it dissolves very many solids. So solvent. So usually a solvent, like water, is a solvent. So a solute is this is a solution. So a solute is like a salt. Anything that you dissolve in water, like sugar, is a solute. So when these two combine, then they form a solution. A solution. So water is a good solvent because it dissolves very many solutes to form solutions. And we also have in our body cells, we have what we call hydrophilic and hydrophobic. We have hydrophobic properties in our cells. So hydrophilic properties are like components in our cells, like in the cell membrane, are the portions in our body cells that love water. Philic means to love. Well, we also have hydrophobic